you're standing at the edge of nothing. A void so vast, it swallows every sense you've got. No stars, no galaxies, not even a whisper of light or sound. It's not empty space. It's the absence of space itself. A concept so alien, your brain struggles to grip it. No time ticks forward. No directions point anywhere. This is the cosmic stage before the curtain rose, before the universe you know exploded into existence. Welcome to the greatest mystery in cosmology. What happened before Predecessor, or the Big Bang? You're about to dive into a question that twists your mind like a pretzel, blending awe, science, and a dash of cosmic wonder. So grab a seat. Let's unravel the origin of everything. Picture this. 13.8 billion years ago. The universe isn't the sprawling cosmos you see in telescope images. It's a singularity, a point so tiny it makes an atom look like a skyscraper, denser than a trillion suns, hotter than anything you can imagine. Then, in a fraction of a second, it bursts. Not an explosion into space, like a firecracker in the sky, but space itself stretching, unfolding, like a cosmic origami blooming into reality. Matter, energy, time, everything you know starts here. But here's the question burning in your mind. What was before? Was there a cosmic prequel? Or is before a trick question that breaks the rules of the universe? The Big Bang isn't just a cool name. It's the moment when everything began. The term was coined in 1949 by astronomer Fred Hoyle, who tossed it out during a radio broadcast, half mocking the idea of a universe with a definite start. He thought it sounded absurd, like a cosmic punchline. But the joke didn't land. Decades of evidence, from the redshift of galaxies speeding away to the faint glow of the cosmic microwave background, have made the Big Bang the bedrock of cosmology. Still, it leaves you with a nagging itch. If this was the beginning, what lit the fuse? Was there a before, or is your brain just stubborn, demanding a story where physics says there might not be one? Let's try to wrap your head around this. You're used to timelines, yesterday, today, tomorrow. But what if time itself kicked off at the Big Bang? Asking what came before could be like asking what's north of the North Pole. There's no there. Physicists like Stephen Hawking have argued the universe might be self-contained, like a sphere with no edges or starting point. Your mind rebels, craving a cause, a before. But what if the universe is like a cosmic DJ, dropping the beat at the Big Bang with no warm-up track? No pre-party, just bam, existence. Here's a bit of humor to lighten the load. Maybe the universe was just chilling before the Big Bang, sipping cosmic coffee, waiting for its cue to shine. Or maybe it was rehearsing, like a band tweaking its set list before the big show. Now, let's paint a sensory picture. Imagine the Big Bang's first instant. There's no sound, because sound needs air, and air doesn't exist yet. No light, because photons are still forming in the chaos, just raw, seething energy, a cauldron of potential hotter than a supernova's core, pulsing with the power to birth galaxies, stars, and the phone you're watching this on. You'd feel nothing, because you weren't there. It's humbling, isn't it? Every atom in your body, every thought in your mind, traces back to that fleeting moment when the universe blinked into being. Here's a quirky detail you might not know. The Big Bang wasn't perfectly smooth. Tiny fluctuations in that primordial soup, variations smaller than a grain of sand, seeded the formation of galaxies billions of years later. These ripples, etched in the cosmic microwave background, are like the universe's baby photo, still visible today. Some physicists wonder if these ripples carry echoes of a pre-Big Bang universe, like cosmic graffiti scrawled by a previous cosmos. It's a wild idea, but they're hunting for patterns that could rewrite the story of existence. This question, what came before, is a cosmic tug-of-war. One side, the traditionalists, says time began at the Big Bang, so before is meaningless. The other side, the rebels, waves equations and theories about a predecessor universe, a cyclic cosmos, or a multiverse where our Big Bang was just one bubble in an infinite foam. It's a debate that's both thrilling and maddening, because it pushes the limits of what we can know. For example, could quantum gravity or string theory hint at a universe that collapsed and rebooted as ours? It's not settled, and that's what makes it exciting. Which side are you leaning toward? Let's zoom out for a second. The universe is 13.8 billion years old. But humans? We've been around for a cosmic blink, about 200,000 years. Yet here you are, a tiny speck on a pale blue dot, daring to ask what came before the beginning. That's the magic of science. It lets you wrestle with questions bigger than yourself. So, here's where you come in. What do you think was before the Big Bang? A void? Another universe? A cosmic reset button? Drop your wildest theories in the comments, because we're just getting started on this journey. As you ponder that, consider this. The universe might be finite, but boundless. Like a cosmic video game where you loop back to the start if you go far enough. This idea comes from the geometry of space-time, which could be curved in ways that make your head spin. And yet, the question of before isn't just a puzzle for physicists. It's a call to curiosity. Every galaxy, every star, every atom in your coffee cup traces back to that singular moment. But was it truly the start? Or just a chapter in a much bigger story? The Big Bang might be the starting line, but the race to understand what came before is one we're all running together. You're hovering at the edge of existence, where everything you know, every second, every moment, dissolves into a question mark. No stars light your way, no clock ticks to guide you. It's not just empty space, it's the absence of space, time, everything. This is the cosmic void before the Big Bang, and you're about to wrestle with a question that makes your brain do somersaults. If time itself began with the Big Bang, how can we even talk about before? You're diving into a riddle that's equal parts science, philosophy, and cosmic magic. So let's roll up our sleeves and explore the tricky beginning of time itself. Imagine time as a river you're floating down. You know its flow. Seconds slip into minutes. Mornings fade into nights. Your coffee goes from steaming to stone cold. Now, picture that river vanishing, shrinking to a single, infinite point. That's the Big Bang for time. The moment the river started flowing, when the cosmic clock began to tick. Before that, no river, no flow, no before as you understand it. Your mind fights this idea. It's built for cause and effect, for stories with beginnings. But what if the Big Bang was the first note in the universe's song, with no melody before it? It's like asking what was playing on your playlist before you hit shuffle. It's a question that feels wrong, yet you can't stop asking it. Let's set the stage. Some 13.8 billion years ago, the Big Bang wasn't just the birth of galaxies and stars. It was when time and space kicked off together. Picture a singularity, a point so dense and hot it defies comprehension, holding all the universe's potential. Then, in less than a trillionth of a second, it expands, weaving the fabric of space-time. This comes from Einstein's general relativity, which says space and time aren't separate. They're a single, stretchy canvas. Before the Big Bang, there's no canvas, no stage for anything to happen. It's not just empty, it's nothing. Try pondering that while your coffee's still warm. And here's a little cosmic humor. Time might move slowly when you're waiting for your pizza delivery, but it moves even slower when it doesn't exist at all. Here's a historical anchor. In 1927, Georges Lemaitre, a Belgian priest and physicist, proposed the primeval atom idea, the seed of what we now call the Big Bang. He suggested the universe started from a single point, with time and space emerging together. His idea was bold, even heretical, but it paved the way for modern cosmology. Today, evidence like the cosmic microwave background, a snapshot of the universe's earliest light, backs this up, showing time began ticking at the Big Bang. But here's a quirky twist. Some physicists think time might not be a straight arrow. It could loop, bend, or even wobble, like a cosmic scribble. That's not something you consider while rushing to a meeting. But it's a real possibility in theoretical physics. Now, let's get sensory. Imagine the instant time begins. No ticking clock, no heartbeat, no rhythm to latch onto. Just a sudden pulse of existence, like the universe flipping a switch. You can't see it. Light doesn't exist yet. You can't hear it. Sound needs air, and air's a distant dream. It's pure chaotic energy, a seething cauldron where time starts to flow, setting the stage for galaxies, planets, and you scrolling through this video. It's humbling to think every moment, every laugh, every deadline, every late-night snack traces back to that first tick of the cosmic clock. The debate over time's beginning is where things get spicy. If time started at the Big Bang, before is meaningless, a question with no answer. Physicists like Stephen Hawking argued the universe is self-contained, like a sphere with no beginning or end in time. You can wander its surface forever without finding a start. But not everyone agrees. Some physicists propose time could have existed in a different form, tied to a predecessor universe or a quantum state where rules get fuzzy. Could time have been a quantum blur, like a song fading in before the beat drops? This clash between a hard start for time and a murky before is a battleground in cosmology, fueled by theories like quantum gravity and string theory. Here's a lesser-known detail. The Planck epoch, the first 10:43 seconds after the Big Bang, marks the dawn of time as we know it. It's the Planck time, the smallest measurable unit where physics still holds. Before that, gravity and quantum mechanics collide, and our understanding breaks down. Some theories suggest this tiny window could hide clues about a pre-Big Bang state, like a cosmic message scratched in the math. Researchers are digging into this with tools like loop quantum gravity, hoping to glimpse what lies beyond. This question isn't just academic. It's about the nature of reality. If time began at the Big Bang, our universe is a standalone story, no prequel needed. But if something came before, a previous cosmos, a quantum spark, a cyclic loop, it rewrites the narrative. Picture time as a river flowing from another, unseen river. That's what keeps physicists up at night, and it's why this mystery is so gripping. So, what do you think? Does time have a definite start? Or is there a before we haven't cracked yet? Drop your ideas in the comments, because we're all chasing this cosmic puzzle together. The Big Bang started the clock, but the question of what came before is still ticking in our minds. You're still catching your breath from wrestling with time's beginning, but now let's zoom into the universe's wildest opening act. The Big Bang wasn't just a spark. It was a cosmic sprint, a burst of growth so fast it makes your head spin. This is cosmic inflation, a fleeting moment, when the universe ballooned faster than light, stretching from a speck to a sprawl in less than a trillionth of a second. But what fueled this insane expansion? And could it whisper secrets about what came before the Big Bang? You're about to ride a cosmic roller coaster that reshaped reality, leaving clues about the universe's deepest origins. Picture the universe at 10 to 36 seconds old, a scorching, chaotic pinpoint, smaller than a proton, brimming with energy. Suddenly, it explodes outward, doubling in size over and over, faster than you can snap your fingers. In a blink, it grows from smaller than an atom to bigger than a galaxy. This is cosmic inflation, the turbocharged kickoff that gave the universe its shape. Without it, the cosmos might have been a clumpy mess, like a poorly mixed smoothie. Instead, we get a smooth, flat universe, ready to host galaxies, stars, and you watching this video. But here's the big question. What powered this cosmic growth spurt? And could it point to a pre-Big Bang reality? Let's set the scene. The Big Bang sparks, and the universe is a roiling soup of energy. Almost instantly, inflation kicks in, stretching space like a cosmic rubber band on steroids. This rapid expansion smooths out any wrinkles, spreading energy evenly across the cosmos. It's why the universe looks so uniform today, like a perfectly baked cake instead of a lumpy batter. But here's the cosmic joke. Inflation was so fast, it's like the universe went from a garage band to a stadium headliner before you could say, Big Bang. And you thought your morning rush to work was hectic. This idea of inflation isn't just a cool story. It's backed by hard evidence. In 1980, physicist Alan Guth proposed cosmic inflation to solve some head-scratching problems in cosmology, like why the universe is so flat and uniform. His theory was a game-changer, and it's been confirmed by observations of the cosmic microwave background, that faint glow from the universe's baby days. Those tiny temperature variations we mentioned before? They match inflation's predictions, like a cosmic signature. But what drove this expansion? Scientists point to the inflaton field, a mysterious energy that acted like the universe's rocket fuel. We don't know its exact nature, but it's the secret sauce behind the cosmos you see today. Now, let's get sensory. Imagine the universe in that first fleeting moment of inflation. There's no light to see, no air for sound, just a silent, invisible surge of energy. Space itself stretches, pulling apart at speeds that make light look like it's crawling. Picture a cosmic tsunami, reshaping reality in a fraction of a second. You'd feel nothing, because you don't exist yet. But the raw power is staggering. Every galaxy, every star, every atom in your coffee cup owes its existence to this moment. It's humbling to think that the universe's grand stage was set in a blink. Here's a quirky fact. Inflation didn't just make the universe big. It made it unfathomably big. The observable universe, 93 billion light-years across, might be a tiny speck in the full cosmos, which could be trillions of times larger. And here's the wild part. Inflation might have left behind gravitational waves, ripples in space-time that could carry echoes of a pre-Big Bang state. Experiments like LIGO are hunting for these waves, hoping to find clues about the universe's first sprint. It's like searching for a cosmic postcard from before the Big Bang. The debate over inflation's cause is where things get spicy. Some physicists think it was a random quantum fluctuation, a tiny hiccup in the cosmic soup that triggered the expansion. Others propose the inflaton field could be a remnant of a previous universe, a cosmos that collapsed or transitioned into ours. This ekpyrotic model suggests our Big Bang was a rebound from a cosmic crunch. with inflation as the spark that set it free. It's a divisive idea, splitting physicists into those who see inflation as a one-off event and those who think it's a bridge to a pre-Big Bang reality. Could our universe be a sequel, built on the ruins of another? Let's zoom out. Inflation explains why the universe is so smooth and flat, but it also raises big questions. Where did the inflating field come from? Was it a spark from nothing, or a hand-me-down from a previous cosmos? Some theories suggest inflation could be eternal, spawning countless universes in a multiverse, each with its own Big Bang. Picture our universe as one bubble in an infinite cosmic foam, each bubble born from its own inflationary burst. It's a mind-bending idea that makes you feel both insignificant and part of something vast. This question of what triggered inflation isn't just a puzzle. It's a key to the universe's origins. If we can crack the code of the inflating field, we might glimpse what, if anything, came before the Big Bang. Scientists are chasing this with telescopes, particle accelerators, and some seriously wild math. And here's a bit of cosmic humor. Maybe the universe just needed a good stretch after being cooped up in the singularity. But seriously, inflation's rapid kickoff shaped the cosmos, and its roots might point to a pre-Big Bang story. What do you think sparked it? A quantum glitch? A cosmic hand-me-down? Drop your ideas in the comments, because we're all in this cosmic chase together. Inflation set the universe in motion, but its origins might just unlock the ultimate mystery. You're still buzzing from the cosmic sprint of inflation, but now let's dive deeper into the subatomic chaos where the universe's biggest secrets might hide. The Big Bang wasn't just a bang. It was a symphony of tiny ripples, quantum fluctuations so small they make a speck of dust look like a mountain. These microscopic hiccups, born in the universe's first moments, shaped everything from galaxies to the ground beneath your feet. But here's the wild part. Could these fluctuations carry echoes of a universe that existed before the Big Bang? You're about to plunge into the quantum realm, where the tiniest sparks might illuminate the greatest cosmic mysteries. Imagine the universe at a fraction of a second old, a sizzling cauldron of energy, still reeling from inflation's rapid stretch. It's not a smooth, calm sea. It's crackling with tiny variations, like static on a cosmic radio. These quantum fluctuations, born in the wild energy of the Big Bang, are smaller than protons, smaller than anything you can fathom. Yet they're the seeds of everything. Galaxy clusters, stars, planets, even the phone you're watching this on. But could they also be a cosmic clue? A faint signal from a pre-Big Bang reality? That's the question that's got physicists buzzing, and you're about to join the hunt. Let's set the scene. The Big Bang sparks, inflation stretches space, and quantum fluctuations ripple through the chaos. These aren't random twitches. They're governed by quantum mechanics, where particles and energy play by rules that feel like cosmic dice rolls. Think of it like a subatomic lottery, spitting out tiny variations in density that later grow into the universe's structure. Without these fluctuations, the cosmos might have been a dull, uniform void. No galaxies, no stars, no you pondering life's big questions. But their role might be even bigger. Some scientists think these ripples could carry fingerprints from a universe before ours, etched in the cosmos's earliest light. Here's a historical anchor. In 1965, physicists Arno Penzias and Robert Wilson stumbled across the cosmic microwave background, CMB, a faint glow from the universe's infancy, while tweaking a radio telescope. Their accidental discovery, initially mistaken for pigeon droppings interfering with their equipment, confirmed the Big Bang and earned them a Nobel Prize. The CMB is more than a snapshot. It's a map of those quantum fluctuations, frozen when the universe was just 380,000 years old. Tiny temperature variations, mere millionths of a degree, reveal where those early ripples were. Scientists study this map like cosmic archaeologists, searching for clues about the Big Bang and maybe what came before. Now, let's paint a sensory picture. Picture the newborn universe, a roiling sea of energy, too hot for light or atoms. Quantum fluctuations ripple through it, like whispers in a cosmic storm. You can't see them. Light doesn't exist yet. You can't hear them. Sound needs air, and air's a distant dream. But these tiny tremors are sketching the universe's future, laying the groundwork for galaxies to form billions of years later. It's like the cosmos is writing its script in real time. With every fluctuation, a plot point that leads to you, right here, right now. Here's a quirky detail. Quantum fluctuations aren't just a Big Bang relic. They're happening all around you, all the time. In the quantum world, particles blink in and out of existence, creating tiny energy ripples. In the early universe, inflation stretched these ripples to cosmic scales, turning subatomic blips into the seeds of galaxy clusters. But some physicists think these fluctuations might carry patterns from a pre-Big Bang universe. Imagine a cosmic tapestry, woven with threads from a previous cosmos, still faintly visible in the CMB. Scientists are scouring the CMB for anomalies, like concentric rings or odd alignments, that could hint at a cosmic prequel. It's like finding a hidden message in the universe's oldest light. The debate here is a cosmic showdown. One camp says quantum fluctuations are just random noise, a natural part of the Big Bang's chaos. Others argue they could be scars from a previous universe preserved when our cosmos was born. Roger Penrose's conformal cyclic cosmology suggests our universe is one in a series, each collapsing and rebooting into the next. Could the CMB's fluctuations carry signals from that earlier cosmos, like echoes in a cave? It's a polarizing idea, with some physicists sticking to the standard Big Bang model, and others diving into wild theories about cosmic cycles or multiverses. Which side are you rooting for? Let's take a step back. These quantum fluctuations, tinier than anything you can imagine, shaped the universe's structure. But their role might be even grander. If they hold echoes of a pre-Big Bang universe, they could rewrite the story of cosmic origins. Scientists are chasing these clues with telescopes like the Planck satellite and experiments like BICEP, hunting for patterns in the CMB that don't fit the standard model. It's like searching for a cosmic Easter egg hidden in the math. And here's a bit of humor. Maybe the universe was just freestyling with those fluctuations, jamming to a beat from a previous cosmos. But seriously, these tiny ripples might unlock the ultimate question. So, what's your take? Are quantum fluctuations just cosmic static? Or could they be whispers from a universe before ours? Drop your thoughts in the comments. Because we're all detectives in this cosmic mystery. The universe's earliest ripples shape the galaxies you see, but they might also point to a reality that existed before the Big Bang. You're still buzzing from quantum fluctuations, those tiny ripples that shape the cosmos. But now, let's push the boundaries of imagination even further. What if our Big Bang wasn't the first curtain call, but a sequel? A cosmic rebirth rising from the embers of another universe. The Predecessor universe hypothesis suggests our cosmos might not be the original act, but part of a grand cycle, born from the ruins of a universe that came before. You're about to plunge into a mind-bending idea that flips everything you thought you knew about the beginning, blending wild theories with tantalizing hints. Ready to explore a cosmic prequel? Picture the universe you know. Galaxies spinning, stars blazing, the Earth humming with life. Not as the first chapter, but as a new volume in an ancient cosmic saga. The predecessor universe hypothesis proposes that before our Big Bang, another universe existed, perhaps with its own galaxies, planets, and even alien civilizations. Maybe it collapsed in a catastrophic crunch, or maybe it transitioned smoothly into ours, with the Big Bang as the spark of rebirth. This isn't just a sci-fi plot. It's a serious idea grounded in physics and math. And it's got scientists buzzing like bees around a cosmic honeypot. Could our universe be a hand-me-down from a long-lost cosmic ancestor? Let's paint the scene. Some 13.8 billion years ago, our Big Bang erupts, birthing space, time, and matter. But what if it wasn't a blank canvas? The predecessor universe hypothesis suggests our cosmos rose from the ashes of an earlier one. Imagine a universe like ours, vibrant and vast, slowly contracting under its own gravity. Stars dim, galaxies spiral inward, until everything collapses into a dense, scorching point, a big crunch. Then from that point, a new Big Bang explodes, launching our universe into existence. It's like a cosmic phoenix, reborn from its own fiery end. And here's a bit of humor to keep things light. Maybe the previous universe left behind some cosmic clutter, and we're just living in its recycled stardust. This idea has deep roots. In the 1920s, before the Big Bang theory dominated, Russian physicist Alexander Friedmann explored expanding and contracting universes through his solutions to Einstein's equations of general relativity. His work suggested the cosmos could cycle through phases of growth and collapse, a precursor to modern cyclic models. While the Big Bang became the go-to explanation, cyclic ideas lingered, and today they're making a comeback. Theories like Roger Penrose's conformal cyclic cosmology and the ekpyrotic model propose our universe could be part of a chain of cosmic reboots, each birthing the next. Now, let's get sensory. Imagine a predecessor universe in its final act. Stars flicker out, galaxies merge in a slow gravitational dance. The cosmos shrinks, growing hotter and denser until it's a seething pinpoint of energy, like a supernova squeezed into a grain of sand. Then, boom! A new Big Bang erupts, unfurling space and time anew. You can't witness this rebirth, no light, no sound, just raw, chaotic energy pulsing with potential. Every galaxy, every planet, every atom in your morning coffee traces back to this moment, and maybe to a universe that lived and died before ours. It's a thought that makes your daily grind feel like a tiny note in a cosmic symphony. Here's a quirky detail. A predecessor universe might have had wildly different physics. Imagine a cosmos where gravity pulls harder, or light moves faster, reshaping how stars and planets form. Maybe its stars burned blue hot, or its planets orbited in days instead of years. If our universe inherited anything from its predecessor, those differences could be encoded in subtle ways, like the strength of fundamental forces or patterns in the cosmic microwave background, CMB. Scientists are scouring the CMB for anomalies, odd shapes or alignments, that might hint at a pre-Big Bang cosmos, like cosmic graffiti left by a previous reality. The debate here is a cosmic cage match. Traditionalists argue the Big Bang was a singular event, with no before needed. Time and space started there, end of story. But rebels like Roger Penrose propose cyclic models, where universes follow one another in an eternal loop. His conformal cyclic cosmology suggests each universe's end blends into the next's beginning, with quantum fluctuations or gravitational waves carrying faint echoes across the divide. The ekpyrotic model takes it further, proposing our Big Bang was a collision between higher dimensional brains, sparking a new cosmos. These ideas split physicists. Some see them as elegant solutions, others as speculative leaps. But they're backed by serious math. Which side are you betting on? Let's take a step back. The predecessor universe hypothesis isn't just about what came before. It's about the nature of reality. If our universe is part of a cycle, time might stretch infinitely backward with no true start. Or if it's one bubble in a multiverse, our Big Bang could be one of countless cosmic sparks. Scientists are hunting for evidence in the CMB, looking for patterns like concentric rings or unusual temperature fluctuations that don't fit the standard model. Telescopes like the Planck satellite are our cosmic magnifying glass, searching for these elusive clues. It's like hunting for a needle in a cosmic haystack, but finding it could rewrite the story of existence. And here's a bit of cosmic humor. If our universe is a sequel, maybe the previous one had a better plot, or at least better cosmic snacks. But seriously, the idea of a predecessor universe changes how you see your place in the cosmos. You're not just in a universe, you might be in a grand, eternal story, with chapters stretching back beyond imagination. So, what's your take? Is our Big Bang a fresh start, or a reboot of a cosmic classic? Drop your ideas in the comments, because we're all part of this cosmic mystery. The predecessor universe hypothesis opens a door to a reality bigger than we ever dreamed. You've just grappled with the idea of a predecessor universe, a cosmos that might have set the stage for ours. Now, let's dive into a concept that's even more outlandish. What if black holes, those enigmatic, light-swallowing titans, are more than cosmic voids? What if they're gateways, or even seeds, for entirely new universes? The notion that a black hole could have sparked our Big Bang, recycling cosmic material from a prior reality, is a mind-bender that pushes physics to its limits. You're about to plunge into a cosmic abyss where gravity, mystery, and creation collide, searching for clues about what came before. Ready to explore whether black holes are the ultimate cosmic recyclers? Picture a black hole. Its gravitational grip so fierce that stars, planets, and even light vanish into its depths. As matter crosses the event horizon, it's stretched into glowing, fiery streams, spiraling into an unknown void. But what if that void isn't a dead end? Some physicists propose that black holes compress matter and energy into conditions so extreme they could birth new universes. Imagine our Big Bang as the other side of a black hole from another cosmos. A spark of creation erupting from a gravitational crucible. Your entire universe, from the swirling galaxies to the coffee in your hand, might be recycled stardust from a black hole's heart. Let's set the scene. Black holes form when massive stars collapse, creating a singularity, a point of infinite density where space-time warps beyond comprehension. It's strikingly similar to the singularity that launched our Big Bang 13.8 billion years ago. Inside a black hole, the laws of physics unravel. Time slows to a near standstill, space twists into knots, and reality becomes a blur. Some theories suggest this singularity could connect to a white hole on the other side, spewing out matter and light to form a new cosmos. Our Big Bang might have been the output of such a cosmic funnel, born from a black hole in a predecessor universe. And here's a cosmic chuckle. Maybe black holes are the universe's ultimate thrift stores, turning cosmic scraps into dazzling new realities. This idea has deep historical roots. In the 1960s, physicist John Wheeler coined the term black hole and explored their bizarre effects on space-time, sparking questions about their cosmic role. While Wheeler didn't see black holes as universe makers, his work inspired others to think big. Today, Physicist Lee Smolin's cosmological natural selection theory suggests black holes spawn new universes, each with slightly tweaked physical laws, like a cosmic lab experimenting with new recipes. If true, our universe could be one of countless offspring, born from a black hole's crushing embrace in a parent cosmos. Now, let's paint a sensory picture. Imagine a massive star nearing a black hole's event horizon. Its light stretches, glowing red as gravity tears it apart. You'd see streams of plasma spiraling inward, like fiery ribbons swirling down a cosmic drain, before vanishing into darkness. Inside the singularity, space and time dissolve into a seething, scorching chaos, denser than 1,000,000,000,000 suns. If this is a portal to a new universe, you'd sense nothing. No light, no sound, just raw, untamed potential pulsing with possibility. Every galaxy, every planet, every atom in your morning coffee might trace back to a black hole's heart in a previous cosmos, reborn in a burst of creation. Here's a quirky detail. Black holes might not destroy everything they consume. Stephen Hawking's discovery of Hawking radiation shows they can leak energy through quantum effects, emitting a faint glow too weak to see. This radiation might carry traces of what's inside, or even what's on the other side. If black holes birth new universes, this radiation could encode faint echoes of their parent cosmos, like a cosmic whisper slipped through a crack. Scientists are studying Hawking radiation with experiments like those at particle accelerators, hoping to find clues about whether black holes are more than cosmic graveyards. The debate here is a cosmic showdown. Traditionalists argue black holes are endpoints. Matter goes in, gets crushed, and that's it. But others, drawing on string theory and quantum gravity, propose they're gateways to new realities. Lee Smolin's cosmological natural selection suggests each black hole spawns a universe with slightly altered physics, like a cosmic game of trial and error. The black hole bounce theory posits that a collapsing black hole rebounds into a new Big Bang, creating a fresh cosmos. These ideas are speculative, splitting physicists between those who stick to established physics and those who embrace the cosmic unknown. Could a black hole have birthed our universe? Or is it just a wild leap? Let's zoom out. If black holes are cosmic recyclers, our Big Bang might be the output of a black hole from another universe, part of an infinite chain of creation. This ties into the multiverse, where each black hole spawns a new cosmos, like bubbles in an endless cosmic foam. Scientists are hunting for evidence in the cosmic microwave background, CMB, looking for patterns like gravitational waves or unusual temperature fluctuations that might hint at a black hole origin. Experiments like LIGO, which detect gravitational waves, could one day spot signals from such a cosmic birth, offering a glimpse into a pre-Big Bang reality. And here's a bit of cosmic humor. If our universe came from a black hole, maybe we're all just cosmic leftovers, reheated for a new cosmic feast. But seriously, the idea that black holes could seed new universes reshapes how you see the cosmos. You're not just in a universe, you might be in a recycled one, forged in a gravitational furnace. So, what's your take? Are black holes cosmic dead ends, or portals to new beginnings? Drop your thoughts in the comments, because we're all chasing this cosmic mystery together. Black holes might just hold the key to what came before the Big Bang. You've just explored the tantalizing idea that black holes might be cosmic recyclers, potentially birthing our universe from the remnants of another. Now, let's turn detective and hunt for hard evidence. Clues that could confirm a pre-Big Bang universe. The cosmic microwave background, CMB, that faint glow from the universe's infancy, might hold patterns like cosmic fingerprints, whispering secrets of a reality before ours. You're about to dive into the cosmic echoes, where science meets mystery, and the sky itself might reveal what came before the Big Bang. Ready to play cosmic sleuth and search for the universe's oldest clues? Picture yourself gazing at the night sky, but instead of stars or galaxies, you're seeing the oldest light in existence. A snapshot of the universe when it was just 380,000 years old. This is the cosmic microwave background, a faint hum of radiation that permeates the cosmos. It's like the universe's baby photo, capturing tiny temperature variations from its earliest moments. But some physicists believe these variations might hold more than just the story of our Big Bang. They could carry traces of a predecessor universe, etched in patterns we're only beginning to decode. You're about to explore the sky for clues that could rewrite the cosmic narrative. Let's set the scene. The Big Bang erupts 13.8 billion years ago, and after inflation's rapid expansion, the universe cools enough for atoms to form, freeing light to travel across the cosmos. This light, now stretched into microwaves, is the CMB we detect today. It's remarkably uniform, but not perfectly. Tiny fluctuations like ripples in a cosmic pond show where matter began to clump, eventually forming galaxies. But here's the twist. Some theories suggest these ripples might carry patterns from a universe before ours, like echoes of a long-lost cosmos. It's a detective story written in ancient light, and you're holding the cosmic magnifying glass. Here's a historical anchor. In 1965, Arno Penzias and Robert Wilson stumbled upon the CMB while testing a radio telescope, initially mistaking its faint hiss for pigeon droppings or equipment noise. Their accidental discovery confirmed the Big Bang and earned them a Nobel Prize in 1978. Today, telescopes like the Planck satellite map the CMB in exquisite detail, revealing temperature variations as small as a millionth of a degree. These maps are like cosmic treasure maps, guiding scientists to clues that might point to a pre-Big Bang reality hidden in the universe's oldest light. Now, let's paint a sensory picture. Imagine the early universe, a glowing fog of plasma, too hot for stars or planets to exist. As it cools, light breaks free, carrying the imprint of those early fluctuations. You can't see this light with your eyes. It's stretched into microwaves. But picture it as a faint, shimmering glow, bathing the cosmos in a soft, ancient hum. It's the universe's first whisper, echoing across 13.8 billion years to reach you. Every galaxy, every star, even the device you're watching this on, owes its existence to those ripples, frozen in the CMB like a cosmic time capsule that might hold secrets of a deeper past. Here's a quirky detail. The CMB might contain Hawking points, concentric rings or hotspots caused by evaporating black holes from a previous universe. Proposed by physicist Roger Penrose, these patterns could be evidence of a cyclic cosmos, where each universe leaves faint marks in the next. Scientists are analyzing CMB data with telescopes like Planck and supercomputers to hunt for these anomalies, which could appear as unusual temperature spikes or alignments. It's like searching for a hidden message in the universe's oldest light, a cosmic postcard from a reality before ours. The debate here is a cosmic cliffhanger. Most physicists agree the CMB's fluctuations are quantum ripples stretched by inflation, perfectly explaining our universe's structure. But others, like Penrose, argue these patterns might hold deeper secrets. His conformal cyclic cosmology suggests our universe is one in a chain, with black holes from a previous cosmos leaving imprints in our CMB. The ekpyrotic model proposes our Big Bang was a collision between higher dimensional branes, leaving unique signatures in the CMB's polarization. These ideas are contentious. Some call them revolutionary, others speculative. but they're driving scientists to scrutinize the CMB for clues that don't fit the standard Big Bang model. Could the CMB prove a pre-Big Bang universe existed? Let's zoom out. The CMB is our best window into the early universe. But it might also be a portal to what came before. If patterns like Hawking points, gravitational waves, or unusual polarizations are found, they could confirm theories of cyclic universes or multiverses. Scientists are using experiments like BICEP and the Simons Observatory to study the CMB's polarization, hoping to detect signals that hint at a pre-Big Bang reality. It's a cosmic puzzle, and every new map brings us closer to an answer, or deeper into the mystery. And here's a bit of humor. Maybe the CMB is the universe's way of sending a selfie from its predecessor, captioned, "Wish you were here." But seriously, the idea that the CMB could hold evidence of a pre-Big Bang universe changes how you see the cosmos. You're not just looking at the sky, you're peering into a cosmic archive. So what's your take? Is the CMB just a snapshot of our Big Bang, or a clue to a deeper cosmic story? Drop your thoughts in the comments, because we're all detectives in this cosmic mystery. The cosmic echoes might just reveal what came before the Big Bang. You've just hunted for cosmic echoes in the microwave background, searching for clues of a pre-Big Bang universe. Now let's step back and ask a deeper question. Why do you, a tiny speck on a pale blue dot, care so much about the universe's deepest mysteries? Why does humanity keep chasing the origins of the cosmos, from ancient campfire stories to billion-dollar telescopes? This quest to understand what came before the Big Bang isn't just about science. It's about your place in an unimaginably vast universe, your connection to a story that stretches back 13.8 billion years and maybe beyond. You're about to explore why this cosmic curiosity defines us and what it means for our future. Picture yourself under a starry night sky, the kind that makes your breath catch. Each twinkling light is a story, a star or galaxy born from the Big Bang's fiery crucible. Your ancestors gazed at the same sky, weaving myths of gods and creation to make sense of it all. Today, you're armed with telescopes, equations, and a relentless drive to know. What sparked the Big Bang, and was there something before it? This pursuit isn't just about facts, it's about wonder, about feeling connected to a cosmos that's both vast and intimate. You're not just asking about the universe's start, you're probing the nature of existence itself. And here's a cosmic chuckle. Maybe the universe is like a shy author, hiding its origin story to keep us guessing at the plot. This quest has deep historical roots. In the 1920s, Edwin Hubble transformed cosmology by showing that galaxies are speeding away from each other, proving the universe is expanding. His discovery, made with a telescope at Mount Wilson Observatory, laid the foundation for the Big Bang theory, showing the cosmos had a beginning. Today, you're part of that legacy, living in an era where the James Webb Space Telescope peers back to the universe's earliest galaxies, and particle accelerators like CERN recreate the Big Bang's conditions. But the question of before pushes you further into a realm where science, philosophy, and imagination intertwine, daring you to ask what lies beyond the cosmic curtain. Now, let's paint a sensory picture. Imagine standing on a quiet hilltop, the night sky ablaze with stars. The air is cool, the silence heavy, and the cosmos feels alive, whispering secrets across billions of years. Every atom in your body was forged in the Big Bang or in the hearts of ancient stars. If there was a universe before, its echoes might linger in the cosmic microwave background, in gravitational waves, or in the very laws of physics that govern your world. This quest to understand before is like tracing your cosmic roots, connecting you to a story older than time itself. It's humbling, making your daily grind feel like a fleeting note in a grand cosmic symphony. Here's a quirky detail. Your ability to ask about the universe's origins might be a cosmic fluke. The laws of physics, gravity, electromagnetism, the nuclear forces, are finely tuned to allow stars, planets, and life to exist. If a predecessor universe had different laws, it might not have supported life, meaning no one would be around to ponder these questions. Physicist Lee Smolin's cosmological natural selection suggests universes evolve through black holes, each new cosmos inheriting slightly tweaked physics. If true, your curiosity about the Big Bang's before might be a byproduct of a universe that just happens to allow inquisitive minds like yours to exist. The debate here is profound. Some scientists argue the question of before is meaningless. Time began at the Big Bang, so there's no before to explore. Others, inspired by cyclic models, multiverse theories, or quantum anomalies, believe clues to a pre-Big Bang reality hide in the cosmic microwave background, gravitational waves, or subtle quirks in physics. This divide isn't just academic. It's about whether your universe is a singular event or part of an infinite tapestry. Experiments like the Simons Observatory and LIGO are hunting for cosmic clues, from polarization patterns to gravitational wave signals, pushing the boundaries of what you can know. Could these efforts prove a cosmic prequel? Or is the Big Bang the ultimate beginning? Let's zoom out. Your quest to understand the universe's origins isn't just about finding answers. It's about what those answers mean for humanity. If the Big Bang was a singular event, you're living in a unique cosmic moment, a one-of-a-kind story. If it's part of a cycle or multiverse, you're a tiny thread in an infinite cosmic weave, connected to realities beyond imagination. Scientists are pushing forward with new telescopes, particle colliders, and bold theories. But you're part of this too. Your wonder, your questions, your comments below keep the quest alive. This pursuit connects you to the stars, to the Big Bang, and maybe to a reality before it. And here's a bit of cosmic humor. Maybe the universe is just teasing us, hiding its origin story like a cosmic cliffhanger to keep us hooked. But seriously, this quest for cosmic origins defines what makes you human. You're a fleeting spark in a 13.8 billion-year-old universe. Yet you dare to ask what came before. So, what's your take? Is the Big Bang the ultimate beginning, or just one chapter in an eternal cosmic story? Drop your thoughts in the comments, because we're all part of this grand cosmic quest. The search for what came before the Big Bang isn't just about the universe. It's about you.